Hello everyone, welcome to Mnemonics. I'm Falguni, our chemistry listener. Let's start with today's question and answer series. Our first question given to us is assertion says reduction of fructose with sodium borohydride forms two products differing in configuration. Reason says a chiral carbon is formed due to the reduction of C2 group with C2. C. Yeah. So what happened is while reduction of fructose on treatment with sodium borohydride, what happens is here you see a see this is planar, right? Like in, for example, in SN2, we had this. So the nucleophile could attack from front as well as from the back side. Similarly, this is also planar. So both the configurations are possible. So this is the chiral carbon that is formed. If you can see, this is the chiral carbon that is formed, so which can either be on this side or on this side. So two isomers are being formed, that is D-mannitol and D-sorbitol. And these are also called C2 epimers. What are epimers? Which differ in configuration at one carbon atom. Alright. So C1, 2, 3, 4, 5. So you see the differences only here and not on any other carbon. So it is C2 epimer. The next question says the monomer of bipolymer DNA is. See, the answer would be nucleotide. Why? Because nucleotide is the monomer of DNA and the nucleotide consists of see, a sugar. Since it is DNA, so it will contain deoxyribose sugar. Then a phosphate group and a nitrogenous base. Okay? Nucleoside is different from nucleotide. So these are the things that nucleotide has. These are the groups that the nucleotide has. So what happens is now you see the structure. This is the structure of DNA. As you can see, this is our base, nitrogenous base. This is our deoxyribose sugar, and this is the phosphate residue. Okay, so the answer would be one. Now let's move on to the next question. Natural sugar and amino acids are respectively. Pay attention to the word respectively. So you have to know one thing that all the natural sugars they are D configuration and all the amino acids are L configuration. Okay, so these are determined by looking at the projection. So the answer would be D and L. Which projection? Fisher projection. It might be written here. Yes, Fisher projection of the molecule you can determine. Now let's see the next question. Select the correct sequence of amino acids present in tripeptide. Three amino acids are there. That is why it is tripeptide. So in all the options we have three. Now let's see how to see which one is the sequence. Let us see the structure of valine, serine, and threonine. If you see, if we add these, let's see, minus H2O. Wait, I'll draw it in a better way. For example, it is like this. Okay. So minus H2O will go. Same would be the case here. And then what will be formed? This will be formed. If you notice, the moieties are same. So it is formed by condensation of these amino acids. That is, this is valine. It has two CH3 groups here. this is serine, and this is threonine. So the correct answer would be this. And how we write valine as VAL, serine is SER, and threonine as EHR. Now let's move to the next question. This is a very good and interesting question. Which of the following compound will give negative Felling's test? The options given to us are maltose, lactose, sucrose, or both 1 and 2. C. Felling's test. The reduce. Firstly, you should know what is reducing sugar and what are non-reducing sugars. Okay. So these contain free keto or aldehyde group. Okay. And they do not have free keto or aldehyde group. So if we have free keto or aldehyde group, that is taken reduced by the Felling's test. So they will give positive Felling's test. So all the reducing sugars will give this test. So among all these, if you see, sucrose here is only the non-reducing sugar. Okay, rest other, these are disaccharides. These are also, but these are reducing sugars. How? That also we will see. So what happens is sugar will not give it. That is the Felling's test, and this would be the answer. See the structure of sugar. Here there is no free OH. But in case of maltose and lactose, if you see, this is OH. So the bond, what happen is, for example, I have this. I'm drawing only this part. Let's suppose it is like this, and we have H. So the electrons will go here, this will come here. Okay. So it will become like this, right? So it has a free group. Similarly for this, these are alpha, so alpha anomers. So this is the case. But here you see there is no OH. There's CH2OH. So it won't be able to form this group. So the answer would be sucrose. Now let's see the next question. Which of the following mentioned amines is produced in the human body? C. Uh, Non-essential amines can only be produced in human body, whereas essential ones cannot be made. Or amino acids, you can write it like this. They contains NH2 as well. So yeah, so essential cannot be made. Out of these, if you see, alanine would be the answer because these are essential amino acids. Okay. See, you have to know these few basic things that you have to study and know. There's no way to like learn them. You have to study them thoroughly. There's no exact concept that can be explained in these questions. Hmm. Now let's see the next question. Cellulose is a polymer of. First of all, what is cellulose? This is a polysaccharide. And what is a polysaccharide? That upon hydrolysis, it will give it will give more than one monosaccharide. Contains of many monosaccharides. Disaccharide contains two, oligosaccharides contains less than 10. So that is how we do differentiate between them. So this is a polysaccharide. Let's see the structure. So this is our structure according to the naming. If we go when see 1, 2, 3, 1, 2, 3, 4. So I'm here 4. So what happens? This is 1 and 4. And this is the glycosidic linkage. Okay. So this is the case here. And these are beta D glucose. Okay. Because the OH is like this before OH was here before the formation of the bond. And now it is like this. So if it was alpha, then the bond would have been like this. Okay, so this is clear now. This would be alpha. So the answer would be 2 beta glucose and C straight chain is there. There is no linking like this. It is there, but not in cellulose for mylopectin and all. Now let's see the next question. Which of the following is C2 epimer of D glucose? Now we know the C2 epimer, what it is. We saw it in the first question. What is the structure of glucose? Wait, I have it here. So if I change this configuration, it will become this. And this is D mannose. Okay? It will have D only because we see it from the L and D are assigned from here. So the answer would be 2. Now let's see the next question. Glucose, when sucrose is boiled with dilute HCl, we get C. Sucrose, it is a disaccharide and it is made up of glucose and fructose, right? So what happens? It is boiled with dilute H positive, that is HCl. So it will form and break into its constituent monomer. So the answer would be 1. Now let's see the next question. Select the biomolecule or molecules that help during the formation of living system. See, what is biomolecule? They are required for our living system for our body, okay? And carbohydrate, it is obviously very important. Glucose and all. The doctor suggests that you should take glucose when you are not in a good condition. The nucleic acids, lipids, all of these are very important. So the answer would be D. Okay, so these are made, the living system are made up of various complex molecules like this. Now let's see the next question. Which of the following pairs is the essential constituent of our food? See, for our food, what do we need? We need, what do we need? We need energy and we need that our building blocks are there. Building blocks of the cells. Like the cell is replicating, it is functioning properly. So the building blocks for bodybuilding, right? So this is contained in carbohydrates. We get energy from carbohydrates. And proteins are the bodybuilding components. So the answer would be proteins and carbohydrates. Now let's see the next question. Select the incorrect statement about the sugar. It is sweet in taste. We all know sugar is sweet. Sugar present in milk is called sucrose. This is wrong because it is lactose. In milk we have lactose. Greek word saccharone means sugar. This is also correct. And not all the carbohydrates are called sugars. This is also correct. Carbohydrates are saccharides. Okay. So let's see the next question. That is 63. Carbohydrates are classified on the basis of their behavior on hydrolysis. They have been broadly divided into C. How do we bifurcate or classify the carbohydrates? As monosaccharides, as disaccharides, That is not the main, uh, disaccharides is not the main classification. As oligosaccharides and as polysaccharides. So it is made of three groups. This is given very clearly in your NCERT. It is mentioned there. You'll see it in the initial paras. Now let's see the next question. Carbohydrate that cannot be hydrolyzed further to give simpler unit of polyhydroxyaldehyde or ketone. This is very simple. The answer would be monosaccharide because it is constituting of one unit, disaccharide or polysaccharides or any oligosaccharide. Whenever we put water, whenever we hydrolyze them, they break into their constituents. Okay, so we obtain the respective monosaccharides upon hydrolysis. So the answer would be monosaccharide. It's already in the simple primary form. And let's see the next question. How many natural monosaccharides are known to occur? This you have to know. This is just written in NCERT and the answer is 20. And some examples can be monosaccharides we know like glucose is there. We have fructose, ribose, and etc. The next question says why polysaccharides are called non-sugars. See, that what is the characteristic of sugar? That they are sweet in taste. So non-sugars will be not sweet. Let's see the option. They yield large number of monosaccharide on hydrolysis. This is true about polysaccharides, but is not relating why is it called non-sugar. They do not taste sweet. This is the answer. This is related to sugar. They are reducing sugars, they are non-reducing sugars. See, they are not sweet in taste, but they can be either reducing or either non-reducing. So all those carbohydrates that will reduce Stelling's and Tollens reagent will be will be reducing at then, and the sugars which do not, they are non-reducing. So the correct answer is B. Let's see the next question. I hope it is visible. Find out the correct option among the following statements. In the reducing sugars, aldehydes and ketonic groups are not free bonded. This is wrong. They are freely available. That is why they are reducing sugars. Maltose and lactose are non-reducing. This is also not. They are reducing sugars. We saw that earlier. Ferrin solution and tolerance reagent are the non-reducing sugar. This is totally incorrect. They can reduce the reducing sugars. All monosaccharides, whether aldoses or ketoses, are reducing sugar. See, these have in see what happens is we have to select the correct thing, right? So the answer would be others are wrong. In disaccharides, what happens is in disaccharides, if the reducing groups of monosaccharides, that is aldehyde and ketone, they are freely available in these monosaccharides. Okay, so that is why they are not bonded to anything, and that is why they are reducing sugar. They are available. Now let's see the next question. It says on what basis are the monosaccharides classified? See, monosaccharides are always classified upon number of carbon atoms and functional group present in them. How? From number of carbon atoms, like we have hexose, we have pentose, and from functional group we decide whether it is aldose or ketose, right? So both are needed for the classification. Then only we can know key what functional group is present, whether it is containing 6 carbon or 5 carbon, whether it is ribose or glucose. Now let's see the next question. Choose the correct statement about glucose. It is also called dextrose. Yes, it is called dextrose. is monomer of starch and cellulose. This is also correct. Its formula is C6H12O6. This is also correct. So all the statements are correct. This is an aldohexose. Okay. Now let's see the next question. This I already explained. Dextrose monomer. Okay. Now the next question. Name the constituents or type of linkage in alpha maltose. See, what is alpha group? How do we know whether a group is alpha or whether a group is beta? For example, I'm not drawing the other OH or H. I'm just telling you how to know whether it is alpha or beta. If OH is here, it is alpha, and if OH is like this, it is beta. Okay. How can you learn this? So see, OH and OH, like opposite sides. It is on opposite sides. Like it is on trans. In trans, we have A, right? That is alpha. So this is how you can learn it. Now let's see what is alpha maltose. This is the structure. Okay. So you can see that this is a glycosidic linkage, and from one carbon to the four of other, from C1 to C4. Okay. So the correct answer would be this. Two alpha D glucose pyranose units with 1,4 glycosidic linkage. The linkage is 1,4. Okay. You could see that. Now let's see the next question. Which one of the following pair is the reducing sugar? Now we know this. We have done it many, many times. Sucrose is not a reducing sugar, and you can see sucrose in every other option apart from B. So these are reducing sugars. And how it is reducing, I already explained you in the first question. That O, for example, it is like here, this is H, then it will go here and like here. So it will be like this. So we have a free group. Now let's see the next question. It says a polysaccharide is composed only of beta D-glucose units, which are joined by glycosidic linkage between C1 of one glucose unit and C4 of next glucose unit. Name of the polysaccharide. Let's draw this structure then. It is said that beta D-glucose units are there. Okay. If it is beta D-glucose, then like this it would be beta, and here the O would be above. Oh, so this is beta linkage, right? And C1 and C4. So what is this? This is the structure of cellulose. Okay, this is 1614 dash. So this is cellulose. It is a straight chain. Okay, containing only beta D glucose units, which are joined by glycosidic linkage. Now let's see the next question. Which of the following statements is not true about the zwitter ion? Right? What is a zwitter ion? It is a dipolar species. It contains negative and positive charge simultaneously. Okay, it has both. Like in S3 positive, the group can be like this, and CO negative. Okay, so let's see the options. It is neutral and does not contain any charges, and we have to tell which is not correct. So first, we got the answer in option A only. In aqueous solution, carboxyl group can lose a proton and amino acid can accept a proton. So giving rise to a dipolar species which will look like this. Now let's see the next question. Which of the following statements is are correct? We have to tell the correct statement. When four, five, six amino acids are linked, then the respective products are known as tetrapeptide, pentapeptide, hexa. See, tetra is for 4, penta is for 5, and hexa is for 6. And peptide we add for the amino acid. So, yeah, this is correct. Polypeptide with more than 100 amino acid residues having molecular mass higher than 10,000 U is called protein. This is also correct because protein is like it is it contains many polypeptides. Okay, many amino acids and polypeptides. Then a protein is formed. So this is also correct. Polypeptide with fewer amino acids are called proteins if they are well-defined conformation of protein, such as insulin. So let's see this statement. How we will define this. But you have to know that the distinction between the polypeptide and protein is not very sharp. Polypeptides, which contain amino acids, okay, amino acids, they usually we call them proteins. And for insulin, we have 51 amino acids. So it is kind of with the fewer amino acids. This is protein and this is for insulin. So C statement is also correct. So our answer is D, all of the above. Now the next question is, on what basis do the fibrous and globule proteins are classified? C. The let's see the structure of globular and fibrous protein. This is the fibrous protein. You could see that these are running parallelly to each other, whereas this is kind of a coil. Okay. So what is the distinctive factor? It is the molecular shape, right? The fibrous proteins are the polypeptide chain that lie parallel or side by side to form fiber-like structure. Okay, these are insoluble in water. Examples are myosin, keratin, that is in our hair, nails. Globular protein, these are folded to form spherical structure and have intramolecular hydrogen bonding. Okay, so these are soluble in water or dilute acid bases. This is hemoglobin, it is there in albumin, in insulin, etc. So the answer would be B. Now let's move to the next part, that is from practical organic chemistry. Practical chemistry, sorry. So for this, what you need to know is the preliminary test, which group belongs to which radical acids and bases, then cations, then anions. You need to know what are the reagents of a particular group. You'll find it in NCERT or in table. Okay. Now let's see. During the precipitation of Mohr's salt solution, which of the following acid is added to prevent the hydrolysis of Fe2 plus ions? So this is a very common and important question, and people tend to do it wrong. So see, Fe2 plus ion, it can be hydrolyzed. Okay. So to prevent this, we add dilute acid. And which dilute acid? That is the dilute sulfuric acid. So this is our correct answer. Dilute sulfuric acid. About Mohr salt, it is also called ammonium ferrous sulfate and it is a double salt. Okay. So what is a double salt? That can break into its constituent salt. It is made of two salts. That is C. NH4 whole twice is there. FeSO4 is there. So it is ammonium and iron. It is made up of two different ions, ammonium and iron, and two sulfate ions. So it is made by combining equal amount of ferrous sulfate and ammonium sulfate. And to prevent the hydrolysis, we use dilute sulfuric acid. Otherwise, they will be again into their constituent. as sodium, ammonium and iron sulfates. Okay. So to prevent, we use Fe, or to prevent the hydrolysis of Fe2 plus, we use disulfuric acid. Now let's see the next question. In these, you also have to know the chemical reactions. This is very, very important. Very important. Then only you will be able to answer the questions. Let's see. In the salt analysis, group 5 radicals, these are group 5 radicals, are precipitated as their carbonates by adding solid NH4Cl and excess of NH4OH solution, followed by addition of NH4 whole twice CO3. Choose the correct reagent for the conformation of Ca2 plus ions. So see, what happens is, let us take an example of carbonate. Then what is needed, that we have to precipitate it. Okay, so ammonium oxalate is used. It is used for the same. It would be oxalate. Let's see the reaction. Let us take an example of. Let us take an example of. No, wait. This is said. This is correct. As their carbons means we have to take this and then precipitate. So first of all, we convert it into oxalate. We do that by adding CH3COOH, and this is a reaction that takes place. Then upon adding ammonium oxalate, what happens? We get calcium oxalate, which is white in PPT. So that is why ammonium oxalate will be transferred. It gives white PPT. Now let's see the next question. This is a very good question. In the salt analysis, Cl negative, Br negative, and I negative are identified by adding HNO3 dilute followed by AgNO3 solution to the salt solution. Choose the correct statement. See what happens when we add Ag plus. These are the anions given to us, and upon adding Ag plus, we get AgI, AgCl, and AgBr. So this is yellow PPT, this is white, and this is pale yellow PPT. What students do and get confused, and even I got confused when I was a student, was that I used to think that AgCl is yellow in PPT, which is not the case. It is white in PPT. So let's see. Chloride gives pale yellow PPT. This is wrong. Bromide gives yellow PPT, which is insoluble in NH4OH. Yes, this is true. We saw now. I negative gives white PPT, which is insoluble in NH4OH. Yes. Iodide gives purple violet gas. No, iodine gives purple violet gas, not iodide. So the correct answer is B and C. That is in option 1. Let's see the next question now. NH4CN test can be used to test. See, we can use it to test Fe3 plus, CO2 plus, and Cu2 plus. Let's see the options. We can see all the options there. So all the above is the answer, but let's see what it does. So with the CO2 plus, Sc negative reacts and it forms blue color complex. Okay, this is the complex we get. With the Fe3 plus, it forms deep red coloration, and with Cu negative potassium, now SCN is called potassium thiocyanide. Okay, it is forming black PPT of this. Okay, so which will then decompose and then it will give white PPT. It is decomposed. Firstly, we get black, and then slowly the precipitate becomes white. So this is the correct answer. Fourth. Let's see the next question. The Bilstein test is used for the estimation. See, this test is used for the estimation of halogens. In the option, let's find which are the halogens there. You can see that only Cl is the halogen, so this is the correct answer. Let's see the next question now. Which of the following gives coal smelling gas with the smell of rotten eggs, like with the dilute H2SO4? Always keep this in mind. If whenever you see smell of rotten eggs, it is because of sulfide. Okay? They on treatment with H2SO4. What does they form? They form H2S, which is having a rotten egg smell. So the correct answer would be three. Now let's see the next question. Which of the following is or are soluble in aquaresia? What is aquaresia? See, it is a mixture of nitric acid and hydrochloric acid in 1 is to 3. Okay. So initially what happens is when we mix both of the acids, initially we get a colorless solution, but within few seconds it forms a yellow solution. And it is very reactive, it can dissolve in mostly anything. So it will be able to dissolve all of these, but it will not be able to dissolve CDS. Keep this in mind. Why? Because it is dissolved in HNO3. Okay. But let's see and assume one example and let's see what happens. So it forms while dissolving HGS, it acts both as oxidizing and a complexing reagent. So the NO3 minus ion in aquaregia will oxidize S2 negative ions and it will give free sulfur, whereas the chlorine ions are used to soluble compounds HgCl4 and it is formed in presence of hydronium ions. Okay, we get HgCl4 2 negative because of chloride ions. So it complexes the mercury. That is, its mercury is very toxic. So the correct answer is 4. Now let's see the next question. A substance on treatment with dilute H2SO4 liberates a colorless gas that produces. The first option given to us is the first situation given to us is turbidity with Berita water and turns the acidified dichromate solution green. Okay, so what happens is what is Berita water? It is aqueous solution of BaOH whole twice. So you know that we for this test it is called sulfate ions. Okay, so it will form white PPT. And to turn acidified dichromate solution, what happens is, see, this is the reaction which is then oxidized to Cr3 positive, which gives green coloration. So all this is because of sulfate, or we can say also because of sulfide ions. Now let's see the next question. A reagent that can separate a mixture of AgCl and AgI is. See what happens is AgCl and AgI, they both are insoluble, okay, in HNO3, in dilute HNO3. And these are soluble in casein. Both of these also hyposolution. But what happens is that and hypo. Let me write it. But for AgCl, wait, AgCl, this is soluble, and AgI is insoluble in NH3 solution. Okay, so the correct answer would be NH3. Let's see the next question. What is the product with NABR and concentrated H2SO4 are heated together. What it forms? Let's see. It forms Na2SO4, Br2SO2, and 2H2. So we get bromine. Now let's see the next question. Sodium nitroprusside gives a violet color in an alkaline solution with. What is sodium nitroprusside? It is FeC and 5 and C. This is used for the detection of S2 negative ions. Okay, we just add few drops to the solution containing S2 negative and we get a purple color violet, purple violet color coloration. So we get the presence of sulfide. Now let's see the next question. The brown ring test for NO3 negative is enabled due to the formation of complex with the formula. Brown ring test is very important. Okay, so we can detect the presence of NO2 negative, NO3 negative, NO2, sorry. So what the complex is? The complex is FeH2O5NO2 plus. Okay, so this corresponds to option number 3. What happens in the brown ring test? It is for the presence of nitrate radical. Okay, so for this we take equal volume of freshly prepared. Okay, FeSO4 and it is mixed with the solution containing the nitrate. So to this solution we add concentrated H2SO4 solution along the sides of the test tube. So this is test tube, so we add it like this. Okay, otherwise it won't be forming a stable ring. So at the junction, say if I had this solution, so at the junction, this is the brown color ring here that will be forming on the walls of the test tube. Now let's see the next question. Two test tubes containing nitrate and bromide are treated separately with concentrated H2SO4. Now brown fumes thus evolved are passed in water. The water will be colored by vapors evolving from the test tube. See, what is done that we had two test tubes and we added H2SO4 to them. And then this was passed in water and we got brown fumes. And we have to tell of which compound it is. Let's see the reaction now with water. So Br2 with water forms brown color, whereas NO2 is colorless upon adding to aqueous solution. So the answer would be bromide. Now let's see the next question. The solution of a chemical compound X reacts with AgNO3 solution to form a white PPT of Y, and which in turn dissolves in NH4OH to give Z. And when it is treated with HNO3, we again get Y. What can this be? So if we have Ag, it is soluble. See, it is soluble here. So it should be with chloride, right? It dissolves in NH4OH. So it should be any of the chloride. But what is the case that it will never form PPT? CS3Cl will never form PPT. So what is left? NaCl. Let's see the reaction first of all. We have NaCl and AgNO3, we get AgCl, which on reaction with the NH4 dissolves and forms this compound. This complex is formed. So that is why it is soluble. Then on reaction with HNO3, we again get AgCl. Okay. So these are the reactions taking place. Our answer would be NaCl. Let's see the next question. When diluted H2SO4 is introduced to an inorganic mixture at low temperature and odorless, colorless gases form. The mixture includes C. Sulfide, it is having burning sulfur odor. Acetate has a vinegar smell, and this is a brown gas, reddish brown gas, right? But we have been given colorless. So, with this, and this is odorless and colorless, so the answer would be carbonate. Hmm. It will give CO2 as written here. Now let's see the next question. When bismuth chloride, BiCl3, is poured into large volume of water, the formula of the white precipitate produces. This is the reaction that we have, and we get ViOs here. This is white. This is bismuth oxychloride. So the correct answer is 3. Let's see the next question. Fe3 plus, Zn2 plus, and CO2 positive cations are present in slightly acidic solution. In slight acidic solution they are present. The reagent that when added in excess to this solution would identify to separate Fe3 plus in one step. See Fe3 plus, this is the third group radical. Okay. And for third group we have the reagent NH4OH in presence of NH4Cl. What will lead to the precipitation would be and form FeOH whole thrice. The precipitate is ferric, we have ferric hydroxide. So how we get it? By adding in it. Okay. So if we add 6 molar NH3 to the slightly acidic solution of iron, will lead to the precipitation of Fe3 plus as FeOH whole plus. So this is what we get. Now let's see the next question. A solution of a substance gives a white PPT on treatment with dilute HCl, which resolves on heating. When H2S is passed through hot acidic solution of black PPT is obtained. See a black PPT, how we obtain the black PPT. See, the reaction is this. The black PPT is of PBS. Obviously, if we are passing H2S, the last product we have will be a sulfide. And among all these, the black PPT is of PB. And this is the reaction that occurs. Now let's see the next question. A solution when diluted with H2O and boiled gives a white PPT. Upon addition of excess NH4Cl and NH4OH, the volume of PPT decreases, leaving behind a white gelatinous PPT. Identify the precipitate that dissolves in NH4OH, NH4Cl. See what happens here is zinc ion is there. Whenever it reacts with water, we have a white PPT of ZnOH whole twice. Okay? And it will dissolve in excess of NH4OH and NH4Cl. Why? Because we will form a tetraamine zinc complex and the complex would be soluble. So this is NH zinc plus 2, this is NH4OH and this is the complex we have. Okay? So this would be our answer. Now let's see the next question, which says the incorrect statement among the following about the nitrate ion test is a dark brown ring is formed at the junction of two solutions. This is correct. We saw it. The ring is formed due to the formation of nitroferrosulfate complex. The brown complex is this. On heating, the nitrate solvent concentrated light brown films are evolved. So the incorrect statement is this. Why? Because the formation takes place of nitrososulfate, nitrosoferrous sulfate. Okay, and not of nitrosulfate. Okay, so these are the reactions taking place, and this is the ring and complex we get. So nitrates are then converted into nitric oxide. And this is what we did. Now the next question is, which reagent is used to distinguish between saturated and unsaturated hydrocarbons? It is a very basic test. We do bromine water test, right? This is for halides. Hmm. AgNO3. Now, what happens in bromine water test? It reacts readily with unsaturated hydrocarbons, that is alkenes and alkynes, by adding across a double bond. Bromine is added, so it is used to distinguish between saturated and unsaturated hydrocarbons. Now let's see the next question. Which functional group is giving a positive test with 2,4-DNPH reagent? What is 2,4-DNPH reagent? It is, so this is 2,4-DNPH reagent and it is used for the detection of carbonyl group. Okay. What happens is it forms compound with orange red people for aldehydes and ketones, and this is the reaction taking place. And this is 2,4-dinitrophenyl hydrazone. That is 2,4-dinitrophenyl hydrazine. And then we got minus H2. Alright. So it is used for the detection of carbonyl groups. Now let's see the next question. What is formed when a carbonyl group reacts with Tollens reagent? We know it is used for the detection of uh, aldehyde. It reacts with aldehydes, but not with ketones. Okay. So, and what is formed is a silver mirror with the inner surface of the reaction vessel. So, like if we have this reaction vessel, so on the inner side, we get silver mirror. Like, so the correct answer would be this. Tollens reagent is ammonical silver nitrate solution and for the oxidation of aldehydes to corresponding carboxyl ion. So this is how the reaction takes place. We have the aldehyde group and Tollens reagent, which then gives the corresponding carboxylate ion. Now let's see the next question. Filling solution is used for the detection of which functional group? Again, this is used for aldehydes. Filling solution is made of two, filling A and filling B. Okay. One is Rochelle salt, another is CuSO4. Rochelle salt is also called sodium potassium tartrate. So this is made in strongly alkaline solution with sodium hydroxide. So it gives a brick red PPT. It reduces and gives brick red PPT. So the answer is aldehyde. It does not produce ketone. Now let's see our next question, which says, which functional group is identified through the use of Lucas reagent? We have already seen this in previous tests. It is used for alcohols to determine and differentiate between 1 degree, 2 degree, and 3 degree, 3 degree alcohols. Okay, with 1 degree there is no reaction. With 2 degree the reaction is there, but with some time is required. And here it is there simultaneously. It contains of ZnCl2 and HCl, right? Anhydrous. Let's see the reactions. These are the reactions. We have this here for 1 degree. For 2 degree, we have this. And this is the mechanism for your understanding. With OH, we had OH, they will react, and here we'll have H2O positive, which is a very good leaving group, and will thus leave, and will leave us alkyl carbocation, and Cl will come here from this. So I hope this was clear. So all the best for the next test, and let's meet in the next video. Thank you.